Algebra I 11.4a multiply two radical expressions. We've talked about this before, the product property for radicals. It says for non-negative numbers, that's positives or zeros, if we have the square root of a times b, we can break it up to equal the square root of a times the square root of b. That's the product property for radicals, and we can use this to multiply radicals and to simplify them. So take a look at this one. We've got the square root of 3 times the square root of 5. We just do 3 times 5 and we get the square root of 15 as our answer. Same with this one. Square root of 7 times square root of 7. That equals the square root of 7 times 7, and we just multiply it together. We could also do 7 squared underneath the radical sign, couldn't we? That's going to be a 49. And the square root of 49 is a 7, isn't it? So we could have just taken one of these, right? If we've got the square root of 2/3 times the square root of 4/5, we just multiply them straight across, and we get the square root of 8/15. And if you have to simplify this, then make sure you do. If we've got the square root of 2x times the square root of 3x minus 1, we put them together under the radical sign and vinculum, and we distribute this 2x as 2x times 3x is 6x squared, and 2x times a negative 1 is a negative 2x. And that's our answer. See? That's not that hard, is it? All right, so sometimes we need to multiply and simplify. So if we see 2 times the square root of 2 times the square root of 14, what we can do is put them both underneath the radical sign, and then we can break that 14 up to a 2 and a 7, can't we? Then, because we have a pair right here, we take one of the pair and put it out in front, and we take the 7, and because it's not a perfect square, it stays inside the square root sign, see? Under the radical sign. See how I did that? Let's take a look at this one. Now we've got the square root of 3x squared times the square root of 9x to the 3rd power. We rewrite it as 3 times 9, and the product rule for exponents says we add exponents when we multiply, right? So now we've got x to the 5th. And we need to break this up because it's an odd exponent. We did that in the previous videos, and there'll be links to those in this description so you could go back and watch it in case you're lost. That means you got ahead of yourself. But when we have an odd exponent, we need to break it into the biggest even one and whatever odd one is left over by itself. Now we can rearrange these, and we can put, instead of 3 times 9 times x to the 4th times x, we could put the 9 up here with the x to the 4th, and then the 3 and the x in the back, because we're not going to get a perfect square out of this, are we? But we will out of the 9. So now we've got the square root of 9, which is 3, times the square root of x to the 4th, which is x to the 2nd power, times the square root of 3x, because that's what's left over, the 3x, see? After we squared those. See? Now that's simplified. Let's try another one. These we're just going to multiply. They don't need to be simplified, really. Might have to FOIL. If you've got the square root of x plus 1 times the square root of x minus 1, we can put them together underneath the radical sign, and we can FOIL this as x squared minus 1x plus 1x minus 1. And these cancel each other out, don't they? Minus 1x plus 1x becomes a 0 pair, and all we're left with is x squared minus 1. See? In this one, we've got the square root of x times the square root of 3x plus 4y. Now we've got two variables. We can put them together under the radical sign as x times 3x plus 4y. We distribute the x to the 3x and the 4y, and we get the square root of 3x squared plus 4xy. See? For this one, we've got to multiply and simplify. If you see the square root of a times b times the square root of a times c, we've got two a's here, don't we? So we can say it's a squared underneath the radical sign times b times c. And we can pull this out when we write it in front here as a single a when we square it. See? We've got a with the root BC. See that? Look at this one. We've got the square root of 15xy squared times the square root of 5x squared y. So I color coordinated this to make it easier on your eyes. The 15 is going to be multiplied by the 5. And even though we could say x to the third, y to the third by adding them together, we don't really want to do that because like over here, we don't want an odd amount. We don't want it to say x to the third, y to the third, because 3 is an odd number. So let's just leave them like this, okay? But we'll put them in order with the x squared here, x, y squared here, y. And this 15 can be broken up into a 3 times 5. Now look, we've got a pair. We've got a 5 and a 5. So what we can do is rewrite it again. We'll put the two 5s together with the two variables that have a square together. And because 3 is not a perfect square and these are alone with no exponents, exponent of 1, what we end up with is we pull one of these down, we pull one of those down, one of those down, and we've got 5xy and square root of 3xy. See? When you see something like the square root of 2a times the square root of 2a, it just equals 2a. Sometimes we need to simplify and sometimes we don't. But remember, we've talked about this before. We can't have a negative inside the square root sign like this, written just like this. It's not a real number. You might see one with the negative sign on the outside, but you won't see it like this. We can't do it. So you can't say the square root of negative 5 times the square root of negative 5 equals positive, the square root of positive 25. That doesn't work. We can't do that, okay? All right, so we just did multiplying two radical expressions to each other, okay? These are all two radical expressions being multiplied to each other. What we're going to do in 11.4b is we're going to multiply and simplify three radical expressions, okay? So we're going to multiply three radical expressions together and simplify them. And like I said before, if you want to see any of the previous videos, which if you haven't seen them and you just happened upon this video, you might want to go back to 11.1a in the playlist and start watching these because they all led up to this one. Or you can pick and choose from the description of this video, whichever one you think might help you, okay? So it's like making a cake. You can't decorate a cake with icing before you've baked it. So if you've missed some, you're going to be in trouble, all right? And this will progressively get you layer upon layer until you understand everything, all right? I really hope you're doing okay. I hope this isn't too confusing. And let's try doing multiplication of three radical expressions. Bye.